I am pleased to introduce this morning session on investigating the choroid. And we will have several presentations on the same topic, so we will have the discussion at the end of the session. And I will start with my presentation about the topographic variation of choroidal thickness view on swept source OCT in healthy eyes. You know that a significant amount of information is already known about choroidal thickness and its variation with age, gender, axial length, diurnal circle. In healthy eyes, mean central choroidal thickness is thought to be about 280 microns. That may vary from 250 microns to more than 450 microns. And choroidal thickness is known to be significantly asymmetric between temporal and nasal part of the fundus. Interest has also been focused on the relationships between the topography of choroidal vessels and the local variations in choroidal thickness in these publications. So the purpose of our study was to assess the topographic variations of choroidal thickness in the posterior pole and beyond in healthy eyes, to determine the location of the maximum thickness point and its distance from the fovea, to correlate the choroidal thickness variations with the course of choroidal vessels, to establish typical pattern of choroidal thickness map, and to compare the choroidal vascularity and its thickness. We examined 20 healthy subjects with no ocular history nor systemic chronic disease, 38 eyes in these 20 healthy subjects with normal fundus. The mean age was 35, and the axial length was comprised between 22 and less than 25 millimeters. We took fundus photo, and OCT and OCTA was recorded on the Topcon swept source with a choroidal map, several choroidal maps, a cube of 9 by 9 millimeter, radial macular map with 12 B scans of 12 millimeter, and on OCTA 9 by 9 and 3 by 9 millimeter. Here are two of the choroidal maps we used. One is made with a 12 B scan of 12 millimeter, and we look at the choroidal thickness in the 6 millimeter circle of the ETDRS chart, 1, 3, and 6 millimeter. And we also recorded the punctal thickness of the choroid in the 9 by 9 choroidal map. Here are some results. Choroidal thickness was always higher in the temporal quadrants than in the nasal ones, which is already known. The superior quadrants were thicker than the other on average, and the choroidal thickness was grossly symmetrical between both eyes. You see here that the mean maximum thickness was found in the 3 millimeter superior quadrant of the ETDRS chart, after in the 6 millimeter quadrant of the ETDRS chart, and it was higher than the central choroidal thickness. We found also that there was symmetric top-down symmetry in only 56% of cases, and the symmetry did not depend on the mean thickness on the mean thickness of the choroid. And you see that you may have a symmetrical aspect in the thick, medium, and thin choroid. And of course, on the contrary, there was an asymmetric pattern in 44% of cases, and here too, it did not depend on the mean choroidal thickness. We also looked at the correspondence between the choroidal thickness and the pattern of choroidal vessels, and mainly veins. And we found that the symmetric patterns corresponded to a symmetric top-down arrangement of the choroidal veins, and the asymmetric patterns corresponded to an asymmetric top-down arrangement of the choroidal veins with oblique watershed zone offset up or down. And more specifically, in the majority of cases, The watershed zone between temporal choroidal veins was horizontal and passed through the macula in 60% of cases, but oblique watershed zones might be superior or inferior to the macula, with large choroidal vein passing through the macula. And if we compare the symmetry between the choroidal thickness and the distribution of choroidal veins, there was a symmetric choroidal thickness pattern which corresponded to 20% of symmetric vein distribution, but in the asymmetric choroidal thickness pattern, 100% was asymmetric in venous distribution. We look also at the location of the thickest choroidal point, and the thickest choroidal point was not retrofoveal, I already said. It was in the superior part of the posterior pole in 60% of cases, 66% of cases, and only in the 1 millimeter central area in 16% of cases. And you see that sometimes the thickest choroidal point could be either in the inferior part of the posterior pole or in the superior part of the posterior pole. We look also at the relationship between choroidal thickness and vascularity, and there was no significant difference in vascularity between areas of thin or thick choroid. We call vascularity index the ratio between vascular surface, the vascular lumen surface, and the choroidal surface, measured on B scans, perpendicular to the direction of choroidal veins and equidistant from the macula. So in this small series of cases, we have shown that in healthy eyes, mean choroidal thickness is the thickest in the superior and temporal quadrants of the ETDRS map. Choroidal thickness values are strongly symmetric between both eyes. There is a substantial inter-individual variation in choroidal thickness, and in cases with axial lengths ranging between 22 and 25 millimeter. Top-down choroidal thickness was symmetric in only 56% of cases and corresponded to a symmetric distribution of the choroidal vein. Asymmetry corresponded to an asymmetric distribution of the choroidal veins, which may cross the macula in 38% of cases, and the choroidal vascularity was not significantly different depending on the choroidal thickness. There is already several publications which have dealt with this evaluation of the choroidal thickness depending on the location in the fundus and the vascularity. In a publication by Vasada groups based on SD-OCT, it was shown that there was large variation in choroidal thickness between individuals. In a very sophisticated paper by the Munich group using a web source OCT prototype running at 100.7 megahertz with only 9 eyes, but very well examined. It has been shown that the lumen of the hallux layer seems to play a major role in determining the global choroidal thickness pattern. And this other large series of cases examined by Mogdi Moussa in Egypt, it has been shown that the maximum of choroidal thickness was in the superofoveal area. And finally, there is an interesting paper by Maria Cristina Savastano and Bruno Lombroso trying to classify the organization of the pattern of the choroidal veins in different typical aspects. And they've shown, quite like us, that the symmetric pattern was found in only 50% of cases. Our study has some limitation. There's a small number of eyes. The classification between symmetric and asymmetric may be partly subjective, and there is some degree of imprecision in the vascular measurement. However, we have tried to correlate various information on the choroid obtained on the same device, thickness topography, choroidal vein pattern, and vascularity, information which are dispersed in other publications. So in conclusion, choroidal thickness varies mainly with age and axial length, it's well known. However, for the same age of axial length and choroidal, for the same age or axial length, choroidal thickness is highly variable. Symmetry or asymmetry are linked to the pattern of choroidal veins, mainly in the hallux layer. Vascularity seems relatively constant regarding choroidal thickness. The reasons or the consequences of these differences are unknown, and the great difference which exists in the choroidal vascular machinery which supply the choriocapillaries between normal eyes is not well understood. So thank you for your attention.